Hi guys, this is Mr. Krieger. It's Common Core Geometry. We're going to be doing Lesson 6 from Unit 8, Part 2, Scaling Perimeters and Areas. So please print up the lesson. Alright, so scaling perimeter. What we mean by that is, let's say we have similar triangles and we want to know what the new perimeter of this triangle is based on that. Well, it scales exactly the way the sides would, okay? It scales exactly the way the sides would, all right? So let's take a look at an example here. If a side of a triangle is 10 and its perimeter is 40, then a similar triangle with a side of 20 would have a perimeter of what? What do you think it would be? Well, if the perimeter is 4 times as big as a side of that triangle, then we need to scale this triangle up by 4 as well. So we're going to multiply by 4, 20 times 4. And that's going to give us 80, which I'll try to squeeze in over here. Okay, let's take a look at this problem. It says that the triangles are similar. This is a key requirement. You can't do this with triangles that are not similar, but as long as the triangles are similar, and it says find the perimeter of this triangle, DEF, we'll follow the steps so you can see what you need to do. Label which triangle is the pre-image and which triangle is the image, and how do you know? What do you think? Well, the pre-image is the one with the information on it. Pre-image is known. And the image is going to be the unknown. This is what we want to find the perimeter of. Okay? So what's the next thing? Well, let's find the perimeter of this triangle ABC. You know how to find the perimeter. You literally add up the sides. 6 plus 8 plus 9 is 23. So the perimeter of this triangle is 23. Find the scale factor of the dilation by comparing the relevant sides. Do you think the scale factor should be greater than 1 or less than 1? Well, we want a perimeter that's larger than the original. So the scale factor should be greater than 1, not less than 1. All right? And you should know, okay, so I'm going to write that down. Okay? So DE, which is from the image, and I'm going to put over here, this is the image, and this is the pre-image. Okay? DE is 15. That's larger than AB. So the scale factor has to be greater than 1. And again, the way you make your scale factor is image over pre-image. Use those numbers. So image over pre-image is going to be 15 over 6, which actually reduces to 5/2. So now to find the new perimeter, take your scale factor and multiply it by the perimeter you found for the smaller triangle, the pre-image, and that's going to get you the perimeter of the image of triangle DEF. Okay? This is the scale factor. This is the original perimeter from the pre-image. Okay? So I hope you understand. It's pretty straightforward. Oh, and I forgot to put something under this so it bleeds through. All right, so maybe you could try this one on your own. Think about it. The two triangles are similar. The perimeter of triangle RST, I'll put a P here for that, is 84. That's not side RT, that's the perimeter. We want to find the perimeter of this triangle. So this one we don't know, we'll call it X. All right, so the first thing we should do is we should make a scale factor. Now the scale factor is going to be image over pre-image. But you need to know which is which. Well, since we know all of this, the stuff that we basically need from this is going to be the pre-image. And this, we don't know something here. This is going to be our image. So when we make our scale factor based on these numbers, it's going to be 12 over 21, which reduces to 4/7. Okay? And that's going to be our scale factor. Now let's take our scale factor and multiply it by the perimeter of this triangle. And that's going to get us the perimeter of the smaller triangle. So perimeter of triangle LMN is 48. Okay? So that's how you do scaling perimeters. Let's look at the next item. Scaling areas. And this is going to be a little bit different. Okay, in the rectangle below, side AB is 2, and side AD is 3. And put the 3 right there, okay? Let's think about this. What's the area of this rectangle? You know how to do that. It's length times width. It's just going to be 2 times 3, which is going to give us 6. Okay, without finding the new sides of the rectangle, what do you think is going to happen to the area if we double the sides of this rectangle? Do you think it's going to double? You think it will triple? You think it might quadruple? Okay, so let's illustrate what happens to the area by making a scaled rectangle from the original rectangle. Let's see. If we're going to double the sides, because everything's going to double here, this side here is going to become 4. So this is going to be 4. And this side here, remember opposite sides of a rectangle are equal, that's 3. This side is going to become 6. What's happening here? Instead of having one rectangle, you have 1, 2, 3, 4. So the new rectangle should be 4 times larger. So it's basically quadruple, okay? The new sides are 4 and 6. I'll make a little diagram here. 4 and 6, and we know 4 times 6 is 24. 24 is 4 times as big as 6, so it's 4 times larger. Okay? What do you think would happen to the original rectangle if we tripled the sides? So what I'm going to do for you is, you could try this yourself. Let's start off with our original rectangle. Do such a great job here, but 2 and 3, right? So if we triple this side, it's going to become 2, 4, 6. If we triple this side, it's going to be 3, 6, 9. How many times bigger, looks like the American flag. How many times bigger do you think this figure is compared to the original rectangle? Well, if you put all the rectangles back in, and again, my drawing is not so great here, they should all be equal size, you could see it's 9 times the size, right? So it's going to be 9 times bigger. We knew our new sides were going to be, if we triple the sides, 2 goes to 6, and 3 goes to 9. Our new area is going to be 54, and 54 divided by the original area is 9 times bigger. Do you see a pattern here? Do you think you understand how this is working? Okay, so this is how you could kind of tell how many times bigger, or in fact smaller, the image becomes. I'm going to lift this up a little bit so you can see it a little more clearly. Here we have these two triangles, A, B, C, and D, E, F. What is the ratio of the smaller to the larger sides? Smaller to larger. So it's going to be 3 to 9. You could have used 4 to 12 as well, but 3 to 9, which is 1/3. How do we find the area of a triangle? Well, it's 1/2 base times height, or base times height divided by 2. So if we wanted to try to find the area of triangle ABC, 3 is like the height and 4 is the base. And the area of a triangle is 1/2 base times height, so 3 times 4 divided by 2 is 6. The area of this triangle is 6. What about the area of triangle DEF? Base times height divided by 2, 12 times 9 divided by 2 is 54. If we make a ratio of the areas from the smaller triangle to the bigger triangle, remember we made a ratio of sides from smaller to bigger, 3 to 9, which was 1 to 3. So now I'm making a ratio of smaller area to bigger area. 6 to 54 becomes 1 to 9. The original scale factor was 1/3 for the sides, but the scale factor for the areas is actually 1/9. So what's happening? Well, if you make the ratio of any sides, if you take that ratio and you square it, I'll rewrite it over here. This is the scale factor that you create for areas. Doesn't always have to be 1 to 9. What you have to do is make the ratio of image to pre-image, image over pre-image, from the sides, and then square that. That will become your scale factor. Let's try an example here. These triangles are similar. The area of triangle TRQ is 30 units squared. I'll put area equals 30. Find the area of this one. Okay, so which one is the image, which one's the pre-image? The triangle you know about, that's going to be your pre-image, and the one that you're missing information from is going to be your image. To make your scale factor, you're going to do image over pre-image. One second. Yes, image over pre-image. So you just take the relevant sides. The image is 12. Pre-image is 8. That actually reduces to 3/2. You don't have to reduce it, but it just makes it a little easier. And then to make the scale factor is going to be that ratio squared. If you square this, it becomes 9/4. That's the scale factor you want to use. If you take that scale factor and you multiply it by the area of the pre-image, you will get the area of the image. So this is 67.5. Does that make sense? All right, last problem. This is just a little bit of a summary of what we've already done. So you could probably do this without my help. Try it out, but I'm going to do it. You should pause the video and try it yourself. Triangle RJM, has an area of 6 and a perimeter of 12. The triangle is dilated by a scale factor of 3. So this is R prime, M prime, J prime. And we want to find, the scale factor is 3. We want to find the new perimeter and the new area. Now perimeter, that just goes up by the regular scale factor of 3. So 12 times 3 is 36. But the area doesn't scale that way. You take the scale factor for the area is going to be the regular scale factor, which is 3, and then you must square that. So the scale factor for the area is going to be 9. So you're going to take 9, you're going to multiply it by the perimeter. You're going to multiply that by the area they gave you. They gave you an area of 6. So 6 times the scale factor is 54. That gives you choice number 3. The area is 54, perimeter is 36. You could do the next homework.